Hello everyone, my name is Hetav and this is one of my first attempts to teach you how to contribute to open source projects. In today's video, I'll actually be going through a project called Sherlock as an example, and the reason I want to make this video is to clarify the different phases that are involved in contribution to open source projects. The first and the most difficult phase is actually to reproduce the project, may it be a bug or a feature, locally on your own machine. So we'll be actually working through cloning it, getting all the dependencies, and working with the repository on our local machine. The second phase is understanding the code structure, especially in repositories that have been maintained for quite some while with a lot of different contributors. The code style can change, and it's especially hard for beginner contributors to understand how to navigate this code, how the code connects. And this is especially important if you're working with issues that revolve around bug fixes or actually some feature enhancements. And last but not least, I'll give you an entire demo of how to begin your journey of contributing to these projects, starting right from cloning these projects to actually making a PR or a pull request that can be eventually merged with these repositories. So let's begin. The project that we're dealing with today is called the Sherlock project. And the Sherlock project is actually a tool for white hat hackers to get all the different social media profiles that are associated with a single username. And this tool, as you can see, has been maintained for quite some while and has upwards of 2,000 commits. No matter the repository, the first thing that you should look at is the number of available issues, especially the open issues over here. And it can get quite overwhelming, especially in these big repositories when you see 65 open issues. The next thing I'd rather recommend for most of the beginners is to go to the label section and filter for something called the good first issue. The good first issue, as it says, is good for newcomers or beginner contributors. Unfortunately for this particular project, there are no good first issues right now. So what we'll rather do is go for just the normal issues and see if we can tackle some of them. For this particular project, I'll be focusing on the issue number 2126, which is Sherlock just gives out false profiles. And once you open an issue, you'll have a description that is all the information you should ideally need for solving the problem. In this description, it says that Sherlock just is giving off found statement even though the profiles may be deleted, banned, inaccessible, etc. Now, let me summarize this problem for you. When you run Sherlock, you get a list of different websites along with the URLs for the particular username you have searched for. In this case, the user has searched for knife.dja_. I'm not even sure if you pronounce it that way. And he or she gets a list of different resources. Now, the complaint is that some of these links don't even exist. And ideally, if these usernames don't exist, Sherlock should not be giving you these URLs. It's only supposed to give you the URLs of usernames that do exist. So you have a conversation. Each issue is usually followed by a conversation. Hi, I would like to take a go at this bug. And then you have some people who are actually contributors or maintainers of these projects who add some more information. So this particular contributor says that it seems like Cults3D and doesn't like dots and usernames, likely needs a regex check, and IEM and Star Citizen are also reproducible. Other sites are listed. I was unable to reproduce. So this is a person who is trying to reproduce the error. And over here, he says that he's able to reproduce the error with IEM and Star Citizen, which means that these URLs actually do not exist, or these usernames do not exist in these websites. And there is a bit of discussion that takes place after this, but I won't be working on that because I've already solved this issue. But we'll be working on how to debug and start from this piece of information and get going. So once you understand the issue in depth, the next step is to go to something called the CONTRIBUTING.md. Most of the repositories have this particular document called CONTRIBUTION.md, which explains to the contributor how they should go about contributing to this project. And in this particular repository, you can just go to docs. This is usually a documentation file, and you'll see contributing.md. So it does a list of instructions. It says adding targets, cleaning up existing targets, and restoring previously removed targets. In this particular repository, the target actually stands for the target URLs or website. Say suppose one of the websites this particular repository checks for is LinkedIn. So LinkedIn would be a target website on which you'll be checking a few usernames. So if you want to add websites, you'll go to the adding targets, cleaning up existing targets, or previously restoring previously removed targets. It is important to understand that contribution.md or contributing.md will not always help you out. For example, in this case, we don't want to do either of these things. We want to actually fix a bug, which is totally different from all the three categories. But nonetheless, it's important to go through this. Next up, we need to understand how to actually get this working, how to get it locally installed. And if we scroll down to what is called the README file, let's hope that they do have some installation instructions, and they actually do. So they have the PyPy program or the method to install it. This is actually what you use if you're using Linux. You have the brew install or the homebrew method, which is for Mac. You have the Docker, which is if you want to use a Docker container, you can do it with Dockers. And there's also usage information about how the command works. It also tells you how to run this particular program. So with Sherlock, you append it with a username as a parameter. You can also append it with multiple usernames, and it should give you a list of different websites. Alright, so for the installation, this is what we have, and now we need to start using it. So the first step you do in order to reproduce this repository locally is to do something called forking a repository. So on the top right, you'll see an option to fork the repository. You click on that small arrow and say create a new fork. What this does is that it creates a copy of this repository in your own account. So you have the repository name, you don't really want to change it, and copy the master branch only. If you know about GitHub branches, master branch is like the main branch where all the work is being done. Sometimes it's also called the main branch. But in this case, yes, we only want the main branch or the master branch, and we create a fork. It will take a few seconds to copy this entire repository into your account. But once this repository has been created, the next step would be to get this locally on your computer. And the step of getting it locally on your computer is what we call as cloning. So we go to the code, we copy this particular URL, which is an HTTPS URL, and we go to a folder where you actually want to store it. I usually call my folders repository_exp for experiments. And I hope you have Git installed. If you do not, it's a simple, easy process. And I'll also link the website where you can actually get Git installed. Once you have Git installed, you can open the Git CLI. And the command you will be using for this is called git clone. So you just have git clone, paste the URL that you're working with. It will take a few seconds to copy it from your remote repository to your local drive. And once it does that, you'll have a local copy to start working with. Let's wait till it actually gets cloned. But until then, one important message that I do want to convey is that when you're working with these remote repositories, it's always a good idea to create a new branch. Don't work on the main branch. Create a new branch that is more descriptive of the problem you're trying to solve. So let us understand what we have over here. So we have the Sherlock folder right here. Now all we need to do is go within the Sherlock folder. And the Git CLI uses the same commands as Linux. You can do cd into the CLI folder. And let me increase the screen size so that it's visible. So now we have all the different files within this Sherlock repository. Now we do need to understand how to work with it. And before we do that, remember the tip. You do want to work on a different branch. So you can always do git checkout -b for creating a new branch. And this we'll just call it test branch. You should usually name it a bit more descriptive, trying to solve the problem. But actually, let me follow my own advice and write fix issue with IEM, which is the website we are trying to solve, website bug that we are trying to fix. Once you do that, you create a new branch, and it will still have the same files that you started with. Now, once we have the repository cloned into our local environment, now what we need to do is build all the dependencies. And for my particular project, I usually like to use Linux, and there's a feature called WSL on Windows machine, which stands for Windows Subsystem for Linux, and that is what I usually use. Once you have the Windows Subsystem for Linux installed, and I will link a video that actually goes through the installation process, you can easily just open it up by typing bash on your address bar, and this opens up the Windows Subsystem for Linux at that particular location. Again, you can do this without using the WSL. It's just that I like to have a Linux environment within my Windows machine because most of the repositories come with installation instructions for either Linux or Mac, and this just makes it easier to work with. So once we have the Windows Subsystem for Linux installed, the first thing you should do is create a virtual environment. And the reason I recommend creating a virtual environment is because you don't want to disturb the settings of your local machine. You just want an environment, more like a case, which has all the dependencies for this project, which does not affect anything beyond the scope of this project. And the reason it's important is because when you're working with multiple projects, sometimes the dependencies clash with each other. And creating a virtual environment is similar to creating a container around your project to make sure that you're not spilling onto your other projects. If you do not like the concept of virtual environment, you can always go with Dockers. As we saw in this particular project, there is an option to Dockerize, to open a Dockerized container and work within it. But I've just chosen to work with a virtual environment. To create a virtual environment, you'll need a command called Python. If you're using Linux, it's usually Python 3, -m, venv, and followed by the name. Because we're working in the Sherlock project, we can just call it Sherlock environment. And once you do this, this will create a new environment for you. However, once an environment is created, that does not mean that you're within that environment. You need to do something called activate the environment. And to activate the environment, we have a command called source on Linux. Be mindful that in order to activate the virtual environment, there are different commands for Linux, Windows, Mac, etc. Alright, so we do have the virtual environment created. Once we have the virtual environment created, we need to activate it using the command called source. So we do the Sherlock environment, you have to go within the bin directory, and there will be an activator there. Once you do that, you'll see on the left hand side of your command that you'll have the Sherlock environment, or whatever you name your environment, pop up. That basically means that you're within this environment. Now let me increase the font size over here, if I can, that is. Perfect. Hopefully that's a bit more legible. So once we have activated this environment, the next step we really need to do is go within the directory. And this is the Sherlock directory that we just cloned from our remote repository. The next step that we want to do is use the pip install command, which was mentioned in the installation readme file. So we can just do pip install, and Sherlock project is what we want to do. Or in other words, you can actually just go to the GitHub repository and use something called the pipx install Sherlock project. Just know that I don't have pipx installed. That's why I'm using something called pip, which as per the notes should work. So we have pip install Sherlock project. I should not have added the .spec. So as you can see, I did make a small mistake with the pip install command. We don't need the .spec because that's a file and you just want to install the Sherlock project. Alright, so your boy here actually faced some unexpected problems. When you run the pip install Sherlock project command, everything seems to be going fine until at some point it just stops updating. If such a thing happens, it's important to understand that having some domain knowledge of how installation works help you in these cases. For example, what we are doing right now is installing a particular library locally. It's similar to like doing pip install numpy. Rather, when you usually do that, what happens is that it comes from a remote source. What we are trying to do over here is we want to access the code locally and make sure that the changes that we are making locally reflect into our library. So when you do pip install Sherlock project, the problem you face is that you're actually installing the Sherlock project from the packaged version which is there on the cloud. Unfortunately, that's not the version you want. You want the version that is locally cloned in your desktop so that when you make changes to it, you're able to see the consequences of that when you run it. So instead of going with the pip install Sherlock project command, you should rather go with pip install dot. And the dot basically means install the library or module in this particular location. That's what the dot stands for. And when you do that, you'll actually see that, okay, this does seem to work. You can even do an ls to see that you have the files and everything out there. You also have a new directory called Sherlock that has been created. So you can go within this directory, or maybe that directory was there always, and I could have missed it. If you go within that directory, you'll have sherlock.py, and this is the file that is the entry point of the program. Alright, so one way to start running this program is to actually just run the sherlock.py. And to do that, you can use the command python3. Again, the 3 is especially if you're using Linux. And you can type in sherlock.py, and remember that you had to append it with a username that you want to search. Remember that there are a few options that come with sherlock.py. And let's just get the options that we have available at our discretion. So the options are, we have help, version, verbose, debug, output, etc. But the one that we are looking for is called the site. So limit analysis to just the listed sites, add multiple options to specify more than one site. Now given that in this video we are just focusing on a website called IEM, it makes sense that when you're looking for the username, so let me just clear this out so that we again get some space for writing. Alright, so to run the particular command with just the IEM site, what we can do is just use python3 sherlock.py knife.dyah underscore and use the parameter IEM for the site. Now you'll see an interesting thing happen over here, which you would not usually suspect, and that also took me aback when I was first recording this video, is that the error would not be reproducible. It will actually give you no websites that have that username. This is a direct conflict with the issue that we just saw. Now, if that happens to you for the first time, there are chances that the issue is not reproducible, at least on your end. However, the reason why we're having it over here is because I already pushed a fix that solves this issue, and it is using a database that is from the cloud, and it has the changes required to fix this issue. Now, how do I know that? Again, if you are tackling it for the first time, the way you would actually know it is go in the help option and look at all the different arguments. Some of the arguments might give you a hint of why such a behavior is happening. That is, why is it not reproducing the bug that you saw in the GitHub issues? And for this particular video, I'll shorten down your time by focusing your attention on a parameter called local. So force the use of local data.json file. And given that I'm creating this video after actually pushing a fix to the remote repository has the right data.json file. And there's also a hint that we'll have to change the data.json file to fix this issue. But for now, we should use the local tag in order to get the latest information, or actually the information or the files that have the bug in them. So we open python3 sherlock.py. Instead of help again, you can just use the knife.dia site em with another tag called local. And this will reproduce the bug. Alright, so we do have the bug reproduced on our end. And this completes the phase 1 of the video. I know it is long, but I just wanted to give you a good practice into how you actually go about reproducing the bug. So just to summarize, you first fork the repository onto your own GitHub account. Then you clone the repository onto your local machine. Then you create a new branch to work on this particular problem. Then you create a new virtual environment, or if you're using a Docker container, to work within that containerized environment. And then you follow the installation instructions, which are either given in the README, or sometimes the README instructions are more about general installation, you should search for installations for the developers, like how exactly developers go about it. And there's also a section on the repository that talks about the pip install dot command that we used. I can show it to you later on. I can link it in the video below. But this completes the phase one. And if you're just interested in reproducing the repository within your local environment, you can stop the video right now. In the next few phases, we'll be dealing with how to go about and understand the code that this repository contains and how to fix the issue. So let me open my trusty VS Code, and what I'll do is I'll add this folder into my workspace. So just navigate to wherever you actually save this particular file. For me, it's the Sherlock experimental. Within that, I go into Sherlock. Within Sherlock, we just realize that the first file that we are running is sherlock.py. Now, it depends on different repositories, different project structures, but the file that you're running is, just the first thing you should really check out. And the reason is that will give you an idea about what's happening. And most of the programming files start with a function called main. So look for this function. And this main function is the entry point of any code. So we try to understand, okay, let me find the main function of this file. And in the main function, we see there's quite a lot of things happening because this is a huge file. And it's a matter of skill and experience to understand what matters to you and what does not matter to you. So, okay, there's the version string, there's the argument passer. So we are looking at different parameters that are being passed to this argument. And of course, we saw in the help related functions that there are quite a few arguments that we are dealing with. This was the site parameter that we are just passing. So this is all just parsing arguments. We can quickly skip through these. Okay, now we have request.get, it gets the sherlock.py, remote version is checking if the version is up to date or not. Doesn't matter to us. All we need to understand is where exactly is it checking whether the website has the username or not, because at this point in time, you want to find out how is that website being called? How are we checking if that username actually exists, right? So, okay, we go through these using to automate request. You can only use output methods. None of this actually interests us. Okay, we have a desired site not found. We have a site.missing append. So this is where we are appending the files. So in org.sitelist, okay, site data all, site information for site insights. Alright, so we're using something like resources data.json for the site information. So let's actually go to resources and data.json, and let's search for our website over here. So the IEM website, it has error type, status code, URL. Okay, URL main. What does this all stand for? That should be our next question, right? So a part of discovering this code is to understand what each of these parameters stand for. And we just noticed that the main file uses this data.json to get information about websites. And we see error type. Let's see what all different kinds of error types are available. So we saw status code is what is set. Do we have any other? Okay, we see a error type of message, and there's some strange combination of literals going on over here, which uses some integer codes. Sometimes the error message, when the error type is message, we're using an error message class, which means it's most likely getting information from the HTML page we're using and looking for this message. Okay, that makes more sense. So the other type of error is message. Okay, for this particular website, someone has the data, no user ID specified, a user does not exist. So what you'll get from the first glance of this is, if the error type is message, we are looking for a particular kind of message. Versus when it is a status code, we are probably looking for HTML status code. Again, when you're contributing to these open source websites, a lot of general information helps you. For example, whenever you put a request to an HTML site, or any website in general, which is of course the base is HTML, you get a status code. And there are status codes in 100s, 200s, 300s, 400s, etc. Right? You must have come across the status code 404, which is the most popular for when trouble arises. So most likely what this is doing is using the status code to find out. And we just went to IEM and we found that IEM also uses status code. So let's go back to the main.py that we had over here, or sorry, the Sherlock.py, and let's look for the status code. So there is a get response function. So it says if response.status code error context none. Okay, that's one way, that's one place where it is being used. We also see if netinfo error type is status code, and that is what would happen for our particular website. Alright, so it has session.head. Again, does not make a lot of sense to me. So what I'll do is, okay, if error type is status code, it will try to get the error code. And most likely this probably, yes. So you can see over here it's checking for that is less than 200, greater than 300, and if that is the case, it usually says query available, or it indicates that the username is most likely available. So let's see what happens. So let's go to our terminal, and we did get this link from our Sherlock program. So we'll go to our browser, paste that link, and see what we actually get. So we do have a page. It says, whoops, we can't find the page you're looking for, but it does load a page. So my guess is that the status code might not be something like 400 or something that's unauthorized or unavailable. To check it, you can easily just use a Python function. Now again, there are multiple ways to check it. One of the ways to check it is using the curl request. So okay, HTTP to 200. What this means is that the status code being returned by this website is 200. And that is probably the issue that we are facing, because we are trying to filter or ascertain whether username exists or not using this thing called status code. And that's what is mentioned in the data.json. However, this website does give you a very valid status code even when the username does not exist. So most likely what we need to do is change it to an error message, because as we saw in the website, there is a message that is being printed. So let me do that. Let me copy that message over here. We'll change this error type to message, and we'll have an error message to not exactly user not found, but to whoops, we can't find the page you're looking for. And let me just save that. So once we saved it, I want to go back and see if it actually made a difference. So the first thing I will do is try to rerun this. And always remember, you need this local because you're changing the JSON file locally. So you must have this local parameter in order to reflect the changes that you're just making. Alright, so we still have that. So the next thing that you should probably do is go to the message. Let's see where message is being used. So if there's error type message, if our data.json was actually being read, this print statement, and I usually just write my name over here so that I can easily search for it. So this print statement should actually run. Now let me try doing that again. Print statements are often deemed to be pretty bad debug tools. Most definitely they're not the best debug tools available, but at the same time they're the most convenient to use because you can just use them to understand if a condition is being executed the way you want it to be. So over here we see that, okay, Hetal here is being run, which means that it's picking up the point that it's actually an error message that we want to check. However, it seems like the error message is not matching. And the reason is, this is the human readable format of what is being displayed over here. It's not the exact HTML you see being rendered to the human eye. And to drive this point home, let me just try to get this in a particular file and get the curl output in the. So we use this particular curl output from this website and put it into something called debug.txt. Alright, so what this does is it creates a new file debug.txt, which I'll just open with a program called vim, which has a search function, and what I'll be searching for is whoops, right? Because that's the message I'm looking for. So it has whoops, we can't. You see the apostrophe, which a human eye just considered as a normal character, is being decoded into this weird combination of symbols and numbers. And that is the reason our error message is not working. And so what we really need to do is copy that and replace it here. So whoops, we can't find the page you're looking for. And let's try that. So we hit Control S, we go back to our bash terminal, and again, you can use any editor, Vim is not a necessity. You can go back, let me just clear a few spaces so it's a bit neat. We run the command again, and hopefully now we should not get that particular website popping up in the list of available websites. And perfect, we do not. Right, so now the search completed with 0 results, which is what we were expecting. And again, the problem was, to summarize, that we are using a status code instead of an error message. So it is important to understand how this particular system is working. Again, the small tutorial does not give you an idea about each of the nitty-gritty workings and connections of the code in this project, but it does go through all the required information we need to understand what's going on. And even though I explained it to you in a few minutes, it does take a few hours to actually understand how the code is being run. And you will end up using a lot of different print statements, a lot of different examples, and sometimes even the debugger to understand how these things are functioning. And once we have that made down, once we actually got the fix to this thing, we go into the phase 3 of this particular video, which is how to combine all the changes that you have made into a pull request, which can be eventually merged within the main branch. So now we go back to the git CLI, which is the one that we used in the first phase of the project to set up our repository. So in the git CLI, you can do git status, which shows that what all have you modified. In our case, we have just modified the data.json file, and that fixed our issue. So in order to add it, we can just do git add dot. Dot basically means it adds everything that we have changed. A good convention or a recommended way to add it would be just to add that particular file which you have changed. And if you try to run git status again, now the file that you have changed does turn into green, which means that, okay, we have recorded that change. The next step is just committing it. So you can write a descriptive commit which says fixed false positive with IEM. And once you've actually committed it, you can write git push origin, and the branch would be fix issue with IEM or IEM. Now what this will do is it will push the changes to your forked copy of the repository. So if we go back to our profile, you'll see that we have fix issue with IEM had recent pushes 4 seconds ago. And we can click on this particular button called compare and pull request. Now what this does is that it will put the changes in your head repository within this particular branch into the Sherlock project's master branch. So this is important to understand. You're trying to create a pull request from the fix issue with IEM, which is your local branch in your local repository, into the global Sherlock project. So the Sherlock project base master. And this is where you need to understand that just clicking on this create pull request will create a pull request in the actual branch. Again, I won't be doing this because the issue has already been fixed and I've already opened a pull request over there which has been merged. So this is just for the demo purposes. Now let me just get rid of this pull request. Let me go to the actual Sherlock project and show you the pull request that I opened up in the first place. So it will now be closed, but let me just show it to you. So this PR aims to solve the false positive issue for IEM website as mentioned in. This is another good point to note, is that you should always mention the issue that you're trying to solve so that it's easier for the reviewer to understand what this PR solves. Then you have debugging the issue. I glanced through the code, and the issue for IEM seems to be the detection algorithm. The error type is set to status code, however a simple code request to an unavailable username shows the response code as 200. This is exactly the same exercise we went through right now. The potential solution. So we should actually check for the error message, which is this one, and validating the fix. This is just a screenshot showing that it does not come up with a result after the fix, which is the expected behavior. And again, this will help your reviewer review this particular pull request and merge it to the branch. So this was a video, an introductory video about how to contribute to a particular project called Sherlock, which is a hacking tool. And I hope you use it for the right purposes. But at the same time, please cut me some slack. This is the first time I'm actually making a public YouTube video about open source, and it has been a pleasure making this video, and I hope you enjoyed it as much as I did. Thank you.